So today we will start with a topic which we missed uh, in the beginning. This is from the first unit, algorithm and flowchart. Okay, basically more of theory thing. Since we did not for the lab, we did not want this topic as such. We started with the actual program. So we have a lot of practice in doing small programs in C now. Now when we come back to algorithm and flowchart topic, it will be easier to understand the theoretical aspect. Rather than learning theory and going into practice, we go to practice first and then come back to theory. That is the approach we follow so that we have a better understanding of the theoretical concepts. Okay, so algorithm and flowchart topic from the first unit. So the definition of an algorithm. You might have heard of this word algorithm before also if you have some exposure to computers. So algorithm, one definition is step-by-step procedure to solve a problem using computer is called algorithm. Step-by-step procedure to solve a problem using computer. How to make computer to solve a problem? In that case, we call it as algorithm. Okay. So if you have the step-by-step procedure how to make say pizza, then we call it as recipe. We rarely call it as, or we don't call it as algorithm. There pizza is made by human being. So here the steps required for the computer to perform a task. Okay. Another definition is in computer science, a sequence of unambiguous steps in to solve a problem is called algorithm. Okay. In computer science, again computer is involved, not for human beings. I'll show an example first. Algorithm for adding two numbers. We start with the first step of start. Step 1, start. Then step 2, input the two numbers to be added and assign them to variables x and y respectively. Okay. Or generally we can leave it as variables, or we want to be specific variables x and y respectively, so that we specify that the variables to be created are named as x and y respectively. Compute z such that z is equal to x plus y. Display the value of z. Then stop. So when we had a program for adding two numbers, this was the exact thing we did. Adding two numbers, almost similar steps we did. Where there the result is called as s rather than z. That's it. So we took the input stored into two variables x and y, then performed the operation, and the result is displayed. And we solved the problem of adding two numbers using computer. For adding two numbers by a human being is not this procedure. We know how to add two, say 4-digit numbers or 5-digit numbers, all those things we know. But here, to make computer to do that, we did not follow the same steps, right? For adding, we just told s is equal to x plus y. But for human to do, this is not enough. We have to take individual digits and add it, then carry over. All those procedure is there. So this we call as how a problem is solved by the computer, that is referred as algorithm, not by the human being. Okay. Now why we need an algorithm? Why we need this kind of representation? Just because this can be understood by everybody. Even if someone is not knowing a programming language, this can be understood by everybody. But if I express it this way, the solution, only those who are having the knowledge of the programming language, basically C programming language or any similar programming language, they will be able to understand how the problem is solved using the computer. But algorithm is a reader friendly representation of the procedure, so that a layman also can understand how to solve the problem of adding two numbers using a computer. So this is the reason exactly why we have algorithmic representation of a solution for the problem in hand. Okay, so algorithmic representation mostly use English-like sentences and minimal mathematical expressions which everybody can understand to express the solution of a problem, how it can be achieved using a computer. Okay, so you don't need the knowledge of a programming language to understand the solution. Some basic English and minimal mathematical knowledge is enough to understand the algorithm. Okay. So normally before the normal procedure for developing an application or solving a problem using computer, the normal procedure is first you will write the algorithm or develop the algorithm, our own thought process and listing down the steps involved, everything. Once that is done, we transform this into one of the programming languages like C or C++. That is a normal procedure. But when it comes to small programs, okay, we can directly do it reasonably. If you are well versed with computers and programming and mathematics, we can directly do it for small programs. That is why we were not bothering much about the algorithm, writing the algorithm part for small problems we have solved so far. Okay. Now some complex problems you take for which you don't know the steps and all, you on paper you work out how this can be done, achieved using computer, and you represent in a user friendly manner so that another person reading the same can understand, okay, how so and so problem is solved or can be solved using a computer. But the representation is simple, plain English and minimal mathematics is used. Algorithm. Another example, algorithm for checking whether a given number is positive or negative. Assume that 0 is also positive. This is the problem. So the algorithmic representation is start, input the number and assign it to a variable x. So if the input is a number and we have to say whether it is a positive number, whatever user entered number is a positive number or a negative number. Okay. So the third step in the algorithm is actually the processing part. If check if x is less than 0, then display then the given number is negative. Otherwise display that the given number is positive. Little long sentence, but still it is plain English sentence. And this is what we can do. If x is less than 0, since I know programming language, I know that I can write it if x less than 0. I can represent it in C language using if x less than 0. Then displaying, we use printf message. For some other language, we use some other function, print function, or in C++ we use cout. In Python we use print. In Java also probably print. Like that, in different languages we will use different functions for displaying a message, but generally in the algorithm we don't specify so that it is more reader friendly for the people, okay, who are laymen who are reading it. Okay, this is what algorithm is, the definition and the example is. So typically this is how we write an algorithm. Okay, but it is not very hard and fast, but we follow this now. There is another representation of a solution of problem. It's called pseudocode. Pseudocode is somewhat between a plain algorithm using English language, but not exactly a representation of the solution in a programming language. Somewhere an intermediate level. Okay, not as easy or easy to read and understand as an algorithm, or not as complex as a real program. That is called pseudocode. It is an informal way of programming description that does not require any strict programming language syntax. It is used for creating an outline of or a rough draft of the program. Okay. So again, here this also pseudocode is also used for representing the solution of a problem, but not exactly following the syntax of a programming language. So I can show the pseudocode for adding two numbers. Okay, just to know what is pseudocode, what is the terminology pseudocode, you will encounter this word sometime later also. I think the spelling is mistake. Okay, so this is the pseudocode for adding two numbers. So procedure name is add, then two inputs are there, x and y. This if I try to compile in C programming language editor or C programming language compiler, it will not compile. May not compile with any programming language, but still some formal notations are there, and but not strictly the syntax of any programming language. Okay, that is pseudocode. Procedure starts here, ends here. But we will not focus further on pseudocode. We will focus on algorithm and another representation called flowchart. Okay, these are different ways of representing the solution of a problem using computer. Okay. Next definition, flowchart. So algorithm, pseudocode, flowchart. Flowchart, it is a pictorial representation of an algorithm. Pictorial representation means representation using pictures or graphical elements. Okay, square or rectangle or such graphical notations, we are going to represent the solution or the algorithm of a problem. It resembles flow of execution of instructions in an algorithm by a computer using, or it represents flow of execution of an algorithm in execution of instructions in an algorithm by a computer using graphical notations. So I'll see. So for that, what knowledge we require is we need to know the various graphical elements or pictures used for different purposes. We have to have a knowledge. For algorithm, we need to know English, basic English and mathematical notations, and then we should be able to figure out how to solve the problem using computer. Then we express it using as an algorithm. In flowchart, we need an additional knowledge of the symbols used for various purposes in the flowchart. Flowchart is a diagrammatic representation of the algorithm or a solution of a problem. So I can show the flowchart directly, an example here. This is the flowchart for adding two numbers. Previously we saw the flowchart for algorithm for adding two numbers. Now it is represented. I have an oval shape in the beginning and in the end. An oval shape. Okay. Then I have a parallelogram for taking input. For the computation, I have a rectangle. Again, output, the symbol is same as taking input. Parallelogram. Then stop. So this is what is a flowchart. So the same algorithm I can represent using flowchart also. Now many people prefer representation of the solution using diagrams. Rather, nobody wants to read these days. All visually appealing things we want, or things which we can understand faster than reading through text. So that is the trend today. So flowchart is the way to represent a solution. Okay, going back, we will go to the different symbols involved in a flowchart. So beginning of the flowchart or the starting step, we use an oval shape. We say normally start instead of beginning. For representing the end also, we have an oval shape. But what is the difference? From the first step, you have an outgoing arrow, and for the last step, we only have an incoming arrow. Natural, right? Last step means there is no further steps following, so only there will be an input or incoming arrow. But for the first step, we have an outgoing arrow. For input output operations, both input, taking the input and displaying the output operation. For these two operations, we use a parallelogram. So here there is an incoming arrow from the previous step. Since this cannot be the first step, start is the first step. Okay, so there will be an incoming arrow and there will be an outgoing arrow. Normally the last step will be here. For the output operation, the last step will be stop. For the input operation, the first step will be there normally. the start. Then the symbol for processing, it is a rectangle. In this rectangle we can add some processing operation like x is equal to a plus b, or if there are multiple steps then we can pack it into one rectangle, or we can divide into multiple rectangles we can do. Okay. So then decision making statements. So we have studied the statement, decision making statement like if else, etc. So for decision making statement, that time also I showed you a diamond symbol. Okay, there should be an incoming arrow here. Okay, it's not having a pointer. Ideally, there should have been an incoming arrow here. So for decision making statement, we use diamond symbol, and we will express, say, x less than y, or x greater than y, or x less than y and less than z. So such statements we will write, and if it is true, we will take one branch. Go out through one branch. If it is true, if it is false, we will go out through another branch. Either this here you can give, or the true part can be here, the false can be here, or true part can be here. So anyway you can, there is a lot of flexibility involved, or true can go here and false can go out from here, like that. Flexibility is there. So input, incoming arrow is here. So from the previous step, the flow is to this step. The sequence is to this step. There are two outgoing options. So the decision making kind of statements. For a multi-way decision making, something what we learned in the last class, switch statement. So the incoming flow, there is an expression or a condition. Then based on the outcome, we take one of the multiple paths. So if you want to represent that kind of thing, we can use multiple arrows. This way. Same diamond symbol only, but the outgoing we are representing multiple channels or multiple outgoing paths here. Multi-way decision making. Now there is something called looping. Sometimes we will have to execute set of statements multiple times. Some statements, say example here, we want to execute multiple times to achieve some task. Okay, we'll come to know about such task soon. But sometimes we want to execute some statements multiple times. So that way, that time we'll still use the decision making kind of symbol, diamond. But true, yeah. One more thing. Instead of true, I can write false and true, or false and yes or no. I can write this way also. Either T, F, or Y, no, or true, false, or yes, no. There is no strict rule guiding that. So true path is here. That means if it is an if block, with if condition is true, we will execute this. Else the rest of the code. Okay. Now here, to represent these statements are to be executed multiple times, we use kind of looping. This is a cycle, right? From here again we go here. If it is true, again we will execute this, and this is the notation for a looping kind of scenario. Looping means certain statements we want to execute multiple times. That means as long as this condition is true, here we are checking a condition, right? Something like x greater than y. As long as that condition is true, we want to execute. In case of if statement, simple if statement, how is it? If it is true, we execute this part once. Otherwise, we proceed. This true part will be executed only once. But here you can see this true block is executing multiple times. Okay, this is not this here. It won't be like if x greater than y. We will put something else to indicate that this statement should be executed as long as the condition we are putting here is true. Okay, we'll see such scenarios soon. Maybe in the next topic there, in the third unit, we will encounter this kind of scenarios. Okay, then flow lines are arrows. We have used already arrows to connect two different symbols, graphical symbols representing two different things. Then connectors, if your problem graph is overflowing one page, you can use connector symbol to connect to a new page. Okay, so far we have not seen an example. If we encounter an example, or to join multiple paths, we can use connector, a circle, multiple incoming paths. To represent that, we can, to join together multiple incoming paths join together, we can use a connector. We'll see one example probably later in the slides. So these are the symbols primarily used: start and end, oval shape; input and output, parallelogram; processing steps, rectangle; decision making, diamond; multi-way decision making, diamond with an extension like this; looping, diamond with the true block having an output again going back to the decision making statement. So it implicates, as long as the condition we put here, this is going to repeat. The statements are going to repeatedly execute. Simple. Okay. Now we'll see some examples for the flowchart. I have already showed you. So for the algorithm, adding two numbers, the algorithm part we saw before. This is the flowchart representation of the same thing, and it is quite flexible. I don't need to write output the given numbers. I can simply say output equal to sum, or display the output. I can, that sentence formation is up to us. Okay, display the output sum, output variable sum, something like that we can put. Okay, we don't need to be so verbal when we are expressing the output the given numbers a and b and the computed sum. Okay, different ways we can express it. Now we did the program for adding finding the area of a triangle given three sides. This is the flowchart representation of that. So once you have the flowchart, writing algorithm is easy. Once you know the algorithm, writing a flowchart is also easy, provided you know the symbols used for different types of statements. Input statement, start, processing, again processing. So two processing steps are there. Either you can put it in a larger block, both the steps you can put it in a larger block, or to make it simpler you can break it down, one step here followed by next step. Here I am not following any C like syntax. So I cannot write like this in C, square root symbol and all those things. I have to call sqrt s into s minus a into, like that I have to write. So this, a normal person without programming language can easily understand with minimal mathematical knowledge. He should be knowing like how the area is computed in, for a triangle, how the area is computed given three sides, the Heron's formula. Now here is a problem, a flowchart of a problem. The problem is extracting units digit of a given number. Extracting the units digit of a given number. So if 1, 2, 3 is given, I want to extract 3. The digit at units position. For any given number, digit at units position. So algorithm is like this. Or flowchart is like this. Input the given number, digit equal to number modulus 10. So here little bit knowledge of this operator is required. A normal person may not be very comfortable with this operator. In normal mathematics we don't use, this is a percentage symbol. Here what it is doing, it is modulus operator. So when you divide any number, or the remainder is what? Remainder is the digit, when you divide any number with 10, the remainder is the number at tens units position. So that idea is used here. So 1, 2, 3 mod 10. Actually, when we studied operators, I had explained this. Modulus operator we can use to extract the digits in a number, given number. So if I directly apply modulus operator with the 10 on a given number, the output is the digit at units position. So I assign it here, then output the digit. Okay. This is what we are doing, extracting the digit at units position using the modulus operator. Any doubt is there? You can unmute and ask me. Okay, next is larger of two numbers. Okay, I'll say larger of two numbers. We are applying most of the symbols we have studied before. Start. This is exactly as an oval kind of thing, or you can two parallel lines connected by two oval sides. So two arcs. So somewhat flexible. Input using parallelogram. Input A and B. A greater than B. Is A greater than B, I can write, or simply if I write A greater than or equal to B, that is also fine. Okay, is A greater than B is little verbal. So, or I can simply write A greater than B. Those who know this notation will be able to identify. We are checking the condition. If yes, output A is larger. If no, output. So for output, both I have two branches here. Here I am displaying A is larger. Here I am displaying B is larger. Then the connecting symbol is used here. Since this branch and this branch is joining, we can use the connector here. The other place where connector is used, if your algorithm flowchart is so large, it will not fit into one page. From one page to another page, if you want to connect, you can use this bubble. Okay, circular symbol called as bubble. The same program we had implemented algorithm. Did we see? Or we had implemented the same program, finding the larger number. So the programmatic implementation of the same thing is here. So I could directly display it here. X is larger. Otherwise here Y is larger. Instead of that, what I did, I stored the result in a variable and finally I displayed. Both are essentially same. In the flowchart I am showing, the output is directly given here within the if block. I should have given printed here only directly. Okay, that is the only difference. Otherwise, essentially, it solves the problem. Flowchart for checking whether a given number is positive, negative, or zero. Okay, looking slightly complex. Here I have one condition checking, only one condition checking, one diamond box, and two branches. One branch displayed out A is larger, other branch displayed B is larger. Here this problem is slightly complex. I have three scenarios. One is a number can be positive or negative, or it can be zero. Here I am discriminating between positive numbers and zero. I want to discriminate here. Okay. So what do I do? Check if n is equal to 0. Then the output message, the output is going this way. Okay. N is equal to 0. Then I display that the given number is 0. In the no part, or in the false part, I am checking n less than 0. I checked n is equal to 0. It is not. In that case, it will come here. If it is true, it will go here and finally it will stop. So all the other things will not be executed. N is equal to 0 is true. If it is false, I am checking for one more condition, that is n less than 0. If this condition is true, I am taking this path, output given number is negative. If n less than 0 is true, that means the number is negative. Else, I can directly conclude that number is positive. Why? Because if n is equal to 0, I will go out through this path and I will reach stop. If n is negative, I will go out through this path and I will reach here. Only if n is positive or greater than 0, I am going to end up here. Now I don't need to explicitly check if n greater than 0. I eliminated, only 3 scenarios were there. First scenario is eliminated here, that's why I came to this place. Second scenario, n negative number, that is also eliminated here by going through this path. Now if both the conditions are false, default case is the given number is positive. I don't need to further check if n greater than 0. I can conclude here only, at this point only I can conclude it is a positive, so I directly display the number is positive and stop. So stopping only one point is there, everywhere we join. So it is the preferred way, one start point and one end point. So if there are multiple branches, intermediate branches, finally they should all join and end at one stop position. Any doubt is there, you can still ask. Yeah. Now this repeating kind of scenarios, I told sometimes some statements we want to repeat multiple times. How to do this in C program we have not seen so far. How to repeat? We know branching statement, if a condition is true, one branch is taken and executed once. If it is false, another branch is taken and executed once. Then we will directly go to the remaining part of the code. Okay. But in this case, we want to execute certain statements multiple times to achieve some task. The task is, given a number, find the sum of all numbers from 1 to that number. Suppose input is 10, I want to find the sum of all numbers from 1 to 10. 1 plus 2 plus 3 plus 4 plus 5 plus like that. So some operation is getting repeated, right? This addition is getting repeated every time. 1 plus 2 plus 3 plus 4 plus like that. So instead of writing 1 plus 2 plus 3 plus etc., I want a general solution. So if I write 1 plus 2 plus 3 plus a sum equal to 1 plus 2 plus 3 plus up to 10, it can find only 1 to 10. Next time if the user enters 100, finding the sum of the numbers from 1 to 100, I cannot change my code and write a long statement like s equal to 1 plus 2 plus 3 plus etc. dot 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 up to 100. I cannot write it. That is not feasible. So in that case, we need to repeat some steps multiple times so that we achieve the same thing, same result. First n numbers. There is a formula, mathematical formula to find the first sum of first n numbers. We will ignore that as of now. To understand the looping or repeating statement concept, we will ignore that. We will take that normal form without the equation. The normal form we will use, taking the individual number and adding. Okay. Sigma x of I, where I is equal to 1 to n. That's what we are implementing here. Sum of first n numbers, how we will represent sigma 1 to sigma I is equal to 1 to n x of I, where x of I is the number. Okay. Now we go for the initial thing. Start, input the value, the n is the user input, and we are initializing a variable I. We are using two variables, I and sum. Sum will be storing the sum of first n numbers at the end of the process, but initially the value of the sum is 0. Okay. I is initialized to 1. Now the repeat statement is repeat as long as I is less than or equal to n. Repeat as long as I is less than or equal to n. Okay. So previously if statement do if I is less than or equal to n or I is greater than n. Previously with the branching statement we did like that. If. But now what we are expressing is Do it as long as I is less than or equal to n. Okay, suppose user is entering, so I will type it here, or I'll type it in a different text box. Suppose user is entering 5, n is equal to 5, user entered, I is equal to 1, sum is equal to 0. So I is equal to 1, sum is equal to 0 initial conditions. I is equal to 1. Now repeat as long as I less than or equal to n. Okay, so first step, so repeat what? These two sub steps. My first step is sum is equal to sum plus I. Sum is equal to sum plus I. Sum is initially 0 and I is equal to 1. So sum is equal to sum plus I means sum is equal to 0 plus 1. Sum is equal to 0 plus 1. Right? Sum is initially 0, I is equal to 1. So in that case, what will be my new sum? So my new sum will be 1, right? 0 plus 1. So I can write it in a different way. I can write it vertically, or I can show. I'll open an Excel sheet. I'll open an Excel sheet and I'll directly show it there. Oh, okay, it is difficult to, yeah. What I'll do is I'll insert a table of three variables. Okay. So online teaching is difficult this way. Oh, everything is gone. In the class, I could have shown it in the board. Here it is. Okay. What is happening? Okay. So I variable I is here. I need to increase the size. This concept is very much related to your next topic we are going to discuss in unit 3. So I'll spend some time on this. So I have variables I. N is not changing ever, so I will keep n separately. Okay. Then I have the variable sum. Initially I is equal to 1, sum is equal to 0. Okay. Next. First time what I am executing, sum is equal to sum plus I. Sum is having 0, I is having 1. So what will be the new value of sum? 1 plus 0, 1. Then I is equal to I plus 1. I is already 1. I is equal to I plus 1. I will become 2. Okay. N is equal to 5. So I can temporarily change it to 5, assuming that we are running this for one time. N is equal to 5. Okay. Now new value of I. So after executing this sub step, we are again going to go back to this step, because here it says repeat as long as I is less than or equal to 5. Right now what is the value of I? It is 2. 2 less than or equal to 5. That is true, right? So since it is true, I am going to repeat the step. Again sum is equal to sum plus I. What is the value of sum? 1. The current value. The original 0 is overwritten by the new value. Current value of sum is 1. Current value of I is 2. So it will become sum is equal to 1 plus 2. And the new value will be sum is equal to sum plus I. That means sum is 2. Sum is 1. I is 2. So it will become sum is equal to 1 plus 2. That means sum will be 3. Okay. Then next step is I is equal to I plus 1. I will become what? 3. You can also respond to this. How this is. Again after that, again go back and check. I less than or equal to 5. It is 3. 3 less than or equal to 5 is true. Again we are going to execute. So I will insert a row below. So new value, so since it is true, 3 less than or equal to 5 is true, again I am going to repeat the step. Sum is equal to sum plus I, sum is 3, I is also 3, I get 6. New value of sum is 6. I is equal to I plus 1, 3 is incremented to 4. 4 less than or equal to 5, that is also true. Okay, so again I have to execute this. So what I will do, I will insert one more row. Again I require one more row, I will insert one now only. Now sum is equal to sum plus I, 6 plus 4. New value of sum is 10. I is equal to 5. I is incremented by 1. So 4 plus 1, 5. 5 less than or equal to 5. That is again true. I will execute this statement one more time. That means sum is equal to sum plus I, 10 plus 5. That is 15. I is equal to I plus 1. 5 plus 1 is 6. Now I will go and check again the last time. 6 less than or equal to 5 is false. The moment it is false, we are no more going to execute the steps, sub-steps. We are going to the next, the steps following. Display the value of sum. What is the value of sum? 15. If you add first 5 numbers, 1 plus 2 plus 3 plus 4 plus 5, how much you get? 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. We got 15, sum of first 5 numbers. Now if I want to generalize, I can simply replace it with n. For any input, any positive number n entered by the user, I will get the sum of 1 to n using this algorithm. Clear? Is it clear? This is slightly complex topic, but I think it is with this way I explained, it is not very difficult to understand. If it is not clear, you can ask me. N is equal to 5. So what it is doing, what this algorithm doing, given an input n positive integer, it will find the sum of all the integers from 1 to that number. Any doubt here? Any question? Or if you understood, somebody please respond. Because this is very important for all the programs you are going to do in most of the programs. Like third module onwards, almost every program will have this looping concept. Repeat some steps, certain steps, as long as some condition is true. Is it clear, guys? No one is responding. How I'll teach if you are not responding this way? Any question? Any doubt? Can I presume that everybody understood? Or are there any? Is it a situation that nobody is there? Can I call someone, some names? Neha. Neha is not there. Shivapriya. You can unmute and.
Yes, sir.
Okay, Shivapriya.
Yes, sir.
So I'm fine. Actually, I will count the attendance. So I'm not I'm finding only 29 people. So I get, after this I get the attendance whoever attended it, and I will track whoever is missing classes regularly, and I will take necessary action. So I understand. I believe it is clear for you. Then we'll move on faster. Here, sum of first n numbers. The flowchart, the corresponding flowchart. This is the algorithm. This is the flowchart. Okay, we used looping kind of this notation. So this is coming here in this part. So I can slightly enlarge it. The same algorithm which I had explained here, I have done using or expressed using a flowchart. So I'll delete this. This is the flowchart. Okay. You can go through this, sum initializing sum to 0, I equal to 1, I less than or equal to n, like that. So I think this slide is repeating. There is another program, finding the factorial of a number. Finding the factorial of a number. So factorial means if 5 is given, what we have to do? 1 into 2 into 3 into 4 into 5. So previous example, we are finding the sum of first n numbers. Here we want the product of first n numbers. Here the algorithm is not much different from the previous one. Only thing in that I initialized factorial value. Instead of sum, I used variable sum. I initialized it to 1 instead of 0. Since 0 into any number. Previously we did sum is equal to sum plus I. But here we are doing fact is equal to fact into I. So if I put fact is equal to 0 initially, it is going to make everything 0. All the multiplication, the result will be 0. 0 into 1, 0. Again 0 into 2, 0. 0 into 3, 0. Instead of that, to avoid that, I am initializing fact to 1. Other than that, the process of repeating is same. As long as I less than or equal to n is true, I am going to repeat these two sub steps. And finally, when I come out of it, that means when the value of I is going to exceed value of n, I will come out of this repeating step 4, and that time I will display the value of fact. That will have the factorial of a number. Okay. So very similar to addition. Only thing is that initialization, I initialize it to 1. Instead of doing addition here, I am doing multiplication, because we have to find the product of first n numbers. Previously it was sum of first n numbers. Here it is product of first n numbers. Any doubt? Somebody unmuted? Okay. So the flowchart is here. Product is equal to product into I. I is equal to I plus 1. Since only two steps are there, we can combine them in a single rectangle box. Here I am initializing in a single block. Input the value of n, but initializing the variables I am doing here. Product equal to 1, sum is equal to 1. Well, I equal to 1. Any question? Meghna?
Sir?
Any doubt?
No, sir.
Okay. So with that we are finishing. This is a small topic. One class was enough. But you will get questions during your internal exam as well as semester end exam to write algorithm and flowchart for simple problems like this. Okay. So you should be knowing the steps. If it is algorithm, how the steps should be written, or flowchart, how to represent it using diagrams. Okay. You have to be aware of the which diagram where to apply. For input, what is the diagram? Decision making, only few are there. Start and stop, same symbol. Input and output, same symbol. Processing, rectangle. Decision making, diagonal. Dimension symbol. Then the arrows corresponding. Decision making normally will have two output arrows. Like that. There is okay, with that we will stop today's class. We will see in the